Okay, so far we have worked on inequalities with one triangle, just comparing the sides and the angles within one triangle. But there is a way to compare two triangles and determine which one has a larger side than the other, or which one has a larger angle than the other. There's a couple of theorems that go with that. One of them is called the side-angle side inequality theorem, and it's quite long to read. The official definition is all written out here. But pretty much what it means is if you have two sides that are the same amongst the two triangles, so something like if I had this triangle ABC, and I had this triangle DEF, say I had two sides that were equal amongst these two triangles, so maybe AB is 5 and DE is 5. That's one pair of sides that's the same. And let's say AC is 6 and DF is 6. That's a second pair of sides that's the same. So that's two pairs of sides that are the same. If the angle that is in between those two sides, it has to be the angle in between them. So that would be angle A and angle D. We can compare those. If angle A is larger than angle D, maybe angle A is 50 degrees and angle D is only 40. Okay, angle A is larger. Because there are two sides that are exactly the same, but the 50 is larger than the 40, then the side opposite the 50 has to be larger than the side opposite the 40. So that would mean BC would have to be greater than EF. If you have two sides the same, but the angle in between is larger in one triangle than the other, then the opposite side is larger in one triangle than in the other. Here's an example. You can see that there's two triangles. There's one to the left, GED, and there's one to the right, GEF. There are two sides here that are the same. DE is 4 and EF is 4, so we know they're equal. And the second side that's the same is GE because they both have side GE. So they have two sides in common. Now here's the kind of tricky part. Sometimes it's easier to draw those two triangles separately so you can see all the information. So if I draw GED by itself, and I'm going to write in here, I have DE is marked and EG was marked. And I draw GEF by itself, I had EF marked and GE marked. So the angles that we're concerned with are angles 1 and 2. Angle 1 is between the two sides in GED, and angle 2 is between the two sides that are marked in GEF. We don't have either one of those measurements, but we can find them. In GEF, we have 39 and 44. So far, we have 83 degrees. Now there's supposed to be 180 in a triangle. So if I subtract 83 from 180, I have 97 degrees left for angle 2. But what about angle 1? Well, if you look at the original picture, angle 1 and angle 2 make a straight line, so they also have to add up to 180. So if angle 2 is 97, angle 1 has to be 83. So we have two pairs of equal sides, but 97 is larger than 83. So the side opposite of 97, GF, has to be larger than the side opposite of the 83, GD. The second theorem is called the side-side-side inequality theorem. It's essentially the opposite of the side-angle-side theorem. We now have two triangles. Let's say ABC again. With two sides equal once again, so maybe AB is equal to DE and AC is equal to DF. But this time we're given the third sides, and one side is larger than the other, so maybe BC is 6, while EF is only 5. Since BC is 6, it's larger than EF, the angle opposite of side BC, angle A, has to be greater than the side opposite, or the angle opposite of side EF. So that would be angle D. And that's what the side-side-side inequality theorem says. Again, it's just a reverse of side-angle-side. Here's another example, which is exactly the same as my last one, so I'm not going to bother to do that. Please remember the exterior angle inequality theorem. We knew that the angle outside of the triangle was equal to angle 3 plus angle 4. That's what we had already known. The angle outside has to be equal We have previously learned that the exterior angle theorem means that the angle outside of the triangle has to be equal to the sum of the two inside. So we had previously learned that angle 1 was equal to angle 3 plus angle 4. The exterior angle inequality theorem changes that into an inequality. It says since angle 1 is equal to angle 3 plus angle 4, that means that angle 1 has to be greater than just angle 3. Or we could say that angle 1 has to be greater than just angle 4. Okay, angle 1 is the sum of angle 3 plus 4. So if we just compare it to angle 3, it's obviously bigger. And if we just compare it to angle 4, it's obviously bigger. That's what the exterior angle inequality theorem states.